Okay, in this chemical equation, we have sodium reacting with water and producing sodium hydroxide and hydrogen gas. One of the first things that we need to do is determine how many atoms we have for each of the elements in the reactant and product side. So we have one atom of sodium, so I'm going to put one. We have two atoms of hydrogen. We have one atom for oxygen. And then on the product side, I have one atom of sodium. And then for hydrogen, I have 1 plus 2 gives me a total of 3 atoms of hydrogen. And then we have 1 atom of oxygen. Next, we're going to identify the loner, also known as the pure element. And that would be the one that is not part of a compound. So this one is by itself. It's not part of a compound, so it's a loner. This is a compound, so that cannot be it. This is a compound, that cannot be it. And then we have another loner over here. Next, we need to identify the 1:1 ratio, also known as the pair element. That would be the element that appears one time in the reactant side and one time in the product side. And it doesn't matter if the subscripts are different, and they can be part of a compound. So sodium, it appears one time in the reactant side, and it appears one time in the product side. So I'm going to put a check mark. Hydrogen, it appears one time in the reactant side. However, it appears 1 and 2 times in the product side. So that cannot be a 1:1 ratio. Oxygen, it appears one time in the reactant side, and it appears one time in the product side. So I am going to put a check mark. Then what we're going to do, we're going to start with the largest 1:1 ratio, also known as pair element. So the 1:1 ratio that you choose, that one needs to have the largest subscript. So that's the one that you're going to start with. If the subscripts are the same, try one of the two. So in this case, sodium and oxygen, they both have a subscript of 1. So I'm personally going to start with oxygen. And the reason for that is because I'm going to try to make this hydrogen into an even number. So I'm going to put a 2 in here. So that means we now have 2 oxygen atoms. Now, so I have 2 oxygen atoms. So that means I need to come over here and make this a 2 as well. And I do that by putting a coefficient of 2. So we're done with the oxygens. And since I put a coefficient of 2, then it locks everything else with a 2. So therefore, I have 2 hydrogens, and then plus 2 hydrogens over here gives me a total of 4 hydrogens. But to make this statement true, I need to put a 1 in here. For the simplicity purpose, I'm putting a 1 in there. So if I have 4 hydrogen atoms, that means I need to come to the left side and check to see if I have 4 hydrogen atoms. And I do, because 2 times 2 gives me 4. So we are done with the hydrogens. Now, okay, this one over here as well. Now, the only thing that is remaining is the sodium. This coefficient made this coefficient made our sodium become 2. Now, check this out. It happens to be that we usually can end with the loners. And the reason for that is because it facilitates the process. So I'm going to put a 2 here. And at that point, everything is balanced out. I have 2 and 2, 4 and 4, and then 2 and 2. So at this point, everything is balanced out.